Comparison between the degradation effect induced by low-pressure air plasma and at atmospheric pressure of the ethyl 3H1-ethoxy 3-phenoxysilidine ammonium chloride solution was carried out by Alarcón-Hernández, Fidel Benjamín, Yáñez-Carrillo, Bartoloa, Fuentes-Albarrán, María del Carmen, and Gadea-Pacheco, José Luisa. All of them researchers from the Autonomous University of the State of Morelos. Water is essential for life and for practically all humanity's activities. Many contaminants are present in the water, so it is necessary to analyze the process for water treatment. One option for water treatment is plasma technology. In this plasma technology, the gas with which the plasma is generated is essential, as is the number of molecules considered to generate the plasma for the degradation of the contaminants. From this perspective, the influence of the number of air molecules present in a plasma on the degradation of a dye is analyzed. The effects of plasma at atmospheric and low pressure as a degradation treatment are compared. The solution to be treated is exposed to air plasma by depositing 250 milliliters in the glass chamber, which is hermetically closed to establish the experimental working pressure inside. One fixed electrode is immersed in the solution, and the other, mobile, is placed between 2 and 5 milliliters from the surface. Given the mobility characteristic, plasma generation takes place in the second electrode. The electrode is distance adjusted to study the solution surface until a visually stable plasma is obtained. When the plasma is generated, its continuity is monitored throughout the treatment. The procedure described is carried out for each treatment at atmospheric pressure 760 torr and low pressure 24 torr. Once the plasma exposure process has started at the corresponding pressure, the measurement or determination of the parameters of interest is carried out every 5 minutes. The plasma exposure treatment is stopped and the variables are measured: temperature, absorbance, pH, COD, and toxicity. Parameters considered for experimenting: treatment time, minutes, 15. Concentration, 17 milligrams per liter. Voltage, 1500 volts. Electric current, milliampere. 10, 15, 20, and 30. Plasma treatments at atmospheric pressure and low pressure dye solution show that the results obtained depend on the experimental pressure considered, number of air molecules in the reaction chamber. Exposure of the solution to plasma at low pressure shows a temperature change behavior dependent on the generating power of the plasma, as well as on the number of air molecules present in each treatment. The reduction of air molecules in the reaction chamber induces a decrease in the temperature of the steady solution. This temperature decrease opposes the temperature increase generated by the plasma's energy supplied to the solution. The plasma at atmospheric pressure for the 4 treatments, T1, 2, 3, and 4, generates a temperature increase in the study solution. The behavior of the solution's temperature change is explainable considering the physical processes that occur in the solution when exposed to plasma at atmospheric pressure. The absorbance behavior of the interest solution after exposure to plasma generated in air-water at atmospheric pressure and low pressure has a decreasing trend depending on the exposure time and the value of the plasma generation current. The decrease in the absorbance value is related to the current applied in each treatment. The greater the electrical current applied, the more significant the decrease in absorbance over time. The absorbance value decreases for treatments at atmospheric pressure, the 1, 2, 3, and 4. The behavior of the absorbance change is different for low pressure treatments. It is smaller and has a quasi-linear trend over time. Air molecules are necessary for the pollutant's degradation. In this type of plasma device, processes of dissociation of oxygen molecules from the air are carried out into atomic oxygen radicals, which recombine to form ozone molecules. These molecules, in turn, can form other free radicals, contributing significantly to the degradation of the compound of interest. The decrease in the air inside of the reaction chamber inhibits the discoloration of the dye of interest due to the decrease or low presence of ionizable gas in which the different primary chemical reactions are carried out. In particular, the solution's pH value decreases as the exposure time for its treatment passes. It occurs for all treatments, atmospheric and low pressure, and increases as the plasma generating electric current increases. In general, the solution increases its level of acidity. The difference in the minimum pH value reached for treatments at atmospheric pressure and low pressure is attributed to three characteristic processes of the experimental system: processes of ionization and dissociation of water, aqueous solution of the contaminant of interest, stimulated by the increase in temperature due to each treatment, generation of new compounds due to the presence of air molecules in greater or lesser percentage inside the reaction chamber, as well as by the presence of free electrons generated by the plasma. In general, carrying out experiments in the presence of a different number of air molecules, atmospheric or low pressure, generates a different change in the pH of the study solution. The greater the number of air molecules and the greater the electrical power to generate the plasma, the more significant the decrease in pH. The COD was determined for all treatments final samples 50 minutes of the interest solution. The COD value shows a decrease in behavior, which allows to infer a decrease in dye concentration depending on each treatment's characteristics. All the treatments show a decreasing trend in the COD value as a function of the applied electric current. The most effective organic matter removal is obtained with the treatments at atmospheric pressure. The highest percentages of COD reduction are attributed to the dye's exposure to non-thermal plasma generated in the presence of a greater number of air molecules. The multiple reactions that take place favor the removal of organic matter. Plasmas in the presence of air can generate ultraviolet light in situ and numerous reactive oxygen species. The germination percentage of hydrated lettuce seeds with the study solution indicates the change in the relative toxicity of the initial solution. In both cases, the positive and negative control reached respective maximums of 71% and 100% germination. The toxicity of the solution decreases more rapidly for treatments at atmospheric pressure. In particular, this experiment shows that the number of air molecules inside the reaction chamber in which the dye of interest is exposed to the plasma is decisive for the degradation efficiency. The presence of air molecules, nitrogen and oxygen, is fundamental for carrying out the chemicals and physical processes that allow the transformation of chemical compounds dissolved in water after their exposure to a plasma. The greater the number of air molecules in the treatments, the greater the degradation of the pollutant. Here are the references for this study.